In this video, we're going to continue talking about proportional relationships. We already looked at what proportional relationships look like in tables. Now we want to see what do they look like in graphs. So that's what we're going to ask in this video is what does a proportional relationship look like on a graph? How do you make a graph of a proportional relationship? And how do you determine the constant rate of change from a graph of a proportional relationship? So let's take a look at some tables and graphs here of proportional and non-proportional relationships. So what does it look like on a graph? So on the left here, I have a table that shows a proportional relationship, and we can see that it's a proportional relationship because we've already learned how to tell that from a table. If we're comparing hours and dollars, every unit rate is $5 per hour. Every one of these ratios is $5 per hour. So we already know that this is a proportional relationship. So let's take a look at what that looks like on a graph. So if we graph all of these points on the grid, so you can see that 2 hours, $10. So hours is on the x-axis and dollars is on the y-axis. So we plot the point 210 right here, and we plot the point 420 right here, and we plot the point 630 right here. And you can see that this creates a straight line, and the line goes through the origin, or 0, 0. So that's what a proportional relationship will look like. Here's an example on the right of a table that is not a proportional relationship. So all of these values here do not have a constant unit rate. This is $5.50 per hour. This is $4.75 per hour, and this is $4.50 per hour. So we know that this is not a proportional relationship. So what does that look like when we put it on a graph? So again, I took these points. Here is 211. The point 211, 2 hours, $11. Here is 4 hours, $19. And here is 6 hours, $27. We can still see that it is a straight line, but it does not go through the origin. So that might tip us off to something that would not be true of a proportional relationship. It's not going to go through the origin. Here's a couple more examples. Here we're comparing miles and hours. And again, on the left, I have a proportional relationship because I can tell from the table. Every one of these ratios is a constant unit rate. It's 60 miles per hour. This is 60 miles per hour, and this is 60 miles per hour. So I know that this is a proportional relationship. So again, when I go to graph this on a coordinate grid, here is 2 hours, 120 miles. Here is 4 hours, 240 miles. Here is 6 hours, 360 miles. Again, I see that it is a straight line, and it's going to go through 0, 0. It's going to go through the origin. So just like the first one, it's a straight line, and it goes through 0, 0. Here's another example of a non-proportional relationship. This ratio here is 40 miles per hour. This is 37.5 miles per hour. And this is 41.6 repeating miles per hour, but I rounded that to 41.7 miles per hour. And if we plot these on the coordinate grid, here is 2 hours, 80 miles, 4 hours, 150 miles, 6 hours, 250 miles. Now we see this is not a straight line. It kind of goes up and down, but it does go through the origin. So it looks like there's two things that have to be true when we have a proportional relationship. And those things are, it has to be a straight line, and it has to pass through the origin. If one of those two is not true, then it will not be a proportional relationship. So now we can tell just from a graph if a relationship is proportional or not, and we don't need to use the table to find that constant rate. So here are a couple examples of graphs that would not be proportional. All I need to do is look at it to tell. This is not proportional because it does not pass through 0, 0. It would have to go through this point right here for that to be proportional and be a straight line. Here it's only a straight line but does not go through the origin, so this is not proportional. This one goes through the origin, but it is not a straight line. This one goes up and down and diagonally, so that is not a proportional relationship. It does not meet both of the requirements. And then finally, this one is proportional. I can tell that because it goes through the origin, or 0, 0, and it's a straight line. So from a graph, it's very easy to tell if a relationship is proportional or not. So here we have a table and a graph for two relationships, and we need to determine if the relationship is proportional. So here we're comparing time and distance, seconds and meters, and just looking at this graph, can you tell if this is a proportional relationship? Well, does it go through the origin? Yes. Is it a straight line? Yes. So is it proportional? Yes, this is going to be a proportional relationship. And if we test it, we can see that every one of these unit rates here is going to be 5 meters per second. Every one of those has a unit rate of 5 meters per second. So that is a constant rate. And then we don't use 0, 0 as one of those because you can't divide by 0. That's undefined. So all the other ones in the table are 5 meters per second. So that is a constant rate. And the graph confirms that this is a proportional relationship. Let's look at the next one that's comparing hours and centimeters. This one is a straight line, but it does not pass through the origin. This one passes through 0, 20. So it started at a height of 20 centimeters and then decreased from there. So it doesn't go through the origin. So I already know that this is going to be a non-proportional relationship. And again, if we look at the table, we can confirm that this is 18 centimeters per hour. This is 8 centimeters per hour. This is 4.6 repeating centimeters per hour, and this is 3 centimeters per hour. So these are all wildly different unit rates, so that confirms it as well. So from the table and from the graph, we can kind of doubly confirm that that is not a proportional relationship. So how do you make a graph of a proportional relationship? Well, the first thing we need to do is identify that constant ratio. Now, that's a theme in proportional relationships, the constant ratio, the unit rate. What is it? And we talked about that, and we learned how to do that in the last video when we talked about proportional relationships in tables. So this is exactly the same thing we would do if we had a table. So find the unit rate. Second step, use the unit rate to create a table. So again, we should already know how to do that. If not, you need to refer back to the last video on how to create a table of values. And then when we do that, we're going to choose at least 3 values of the independent variable in our table. So we get to choose those. We can pick whatever we want. So we'll pick some that will fit on the graph. Because we need at least 3 points so that we can find out where our line is. And then lastly, we're going to use those values in the table to graph the coordinates on the grid. And the independent variable is always on the x-axis, and the dependent variable is always on the y-axis. So make sure that you're graphing those correctly and not graphing them backwards. Otherwise, you won't end up having your graph look like a proportional relationship. So here's a couple of examples here that we're going to graph, and we're going to determine whether they're proportional by graphing them. So here we already have a table of values created, so I'm just going to plot these points on my grid here. So here the number of tickets is our independent variable, so that goes on the x-axis, and the cost is the dependent variable, that's going on the y-axis, and the 0.26 is, this is counting by 2s, so this is 2, 2, 4, 6. So that one's right there. 4, 8. 4 tickets would cost $8. So here's 4 tickets and $8. 6 tickets would cost $10. So that's here. 8 tickets would cost $12. And 10 tickets would cost $14. That's right here. So I can see this is a straight line. So if I continue this straight line, that is not going to go through the origin. So it's a straight line, but it does not go through the origin. So this is not a proportional relationship. And I can tell that just from graphing it. And again, we could check that with these unit rates. This is $3 per ticket. This is $2 per ticket. So I already know that it's not constant. This is 1.6 repeating dollars per ticket. This is $1.50 per ticket, and this is $1.2 per ticket. So you can see that the unit rate is always changing here. So that is definitely not proportional. Let's look at the next graph and let's plot this on our grid and see if it's proportional. Number of hot dogs and cost. So 2 hot dogs cost $6. So I'm going to put that point on my graph. And this is hot dogs here. This is my independent variable. That's going to go on the x-axis. 4 hot dogs would cost $12. 6 hot dogs would cost $18. 8 hot dogs would cost $24, and 10 hot dogs would cost $30. And that is a straight line, but you would use a ruler on this, of course, and it goes through the origin. So straight line through the origin. So yes, this is a proportional relationship. The number of hot dogs is proportional to cost. And again, if we check that in the table, these are all $3 per hot dog. That's a constant unit rate in the table. All of these are $3 per hot dog. So we can confirm that again on the table or on the graph. So here we're going to start from scratch. All I have is a description. I'm not given a table and I'm not given a graph. So we're going to take a proportional relationship and turn it into a table and then turn it into a graph as well. It says every can of frozen orange juice concentrate requires 4 cups of water. Graph the relationship between cans of concentrate and cups of water. So cans of concentrate and cups of water are my 2 variables. So I need to identify which one's independent and which one's dependent before I can find my constant ratio. And the independent variable here is cans of frozen juice, because I need to know how many cans I have before I can determine how many cups of water I'm going to need to make the juice. So the cups of water depends on how many cans of concentrate I have. So first of all, I need to identify those 2 things. What's the independent variable? What's the dependent variable? And then we learned in the last video to find our unit rate. It's the dependent variable divided by the independent variable. So it takes 4 cups of water for every 1 can of frozen juice. So that's 4 cups per 1 can, which is a unit rate of 4 cups per can. So there's my unit rate. There's my constant ratio in the relationship. So now I'm going to use that to make a table. So in my table, my independent variable is always going to go first. So this is cans, and this is going to be cups. So where I said I can choose any values I want or any number of cans that I want. So I'm going to choose 1, 2, and 3. I'm going to get creative there. It's nice to use lower numbers so that I know they'll fit on my graph, and then I can use that unit rate. So if it's 4 cups for every can, if I have 1 can, that's going to be 4 cups. If I have 2 cans, that's going to be 8 cups. And if I have 3 cans, that's going to be 12 cups. So here I've created my table of values from my unit rate, and now I can use that table to make my graph. Now, again, on the graph, the independent variable is always going to go on the x-axis. So this is going to be cans. And cups is my dependent variable. So that's going to go here. I need to make sure that everything's going to fit on my graph. 1, 2, and 3 is all I need here. So I'm just going to spread this out a little bit. Always start with 0. And then I'm going to go every other line is going to be a can. 2, 3, 4, 5. So 1, 2, and 3 cans will fit on my graph. And then I need to be able to fit 12 cups on my graph. So again, I always start with 0, and I'm going to have 10 here. So I can't count by 1s, so I'm going to count by 2s. This will be 2, this would be 4, 6, 8, 10, 12, 14, 16, 18, 20. And it's okay to go beyond what's in your table as long as you count consistently and you start with 0 and don't just put these numbers only on your graph. So it's kind of like creating a little ruler here. So now I can plot the points in my graph. 1 can would require 4 cups. So that point would be right here. That's 1 can and 4 cups. 2 cans would require 8 cups. And 3 cans would require 12 cups. And I can see that that is going to be a straight line that goes through the origin, and there's my graph that compares the number of cans to the number of cups that I would need for my orange juice. Lastly, how do you determine the constant rate of change in a graph of a proportional relationship? So if we're given a graph, how can we find that constant unit rate? Because we know how to do it in a table, but how do you find it in a graph? So when 2 quantities are proportional, any point on the graph can be used to find the constant rate of change, just like any pair of values in a table could be used to find it, because they're all going to be the same regardless of which pair of numbers you use to find the unit rate. So for any point on the graph, you're going to have an x value and a y value. The constant rate of change, or the unit rate, is the y value divided by the x value, which is going to be the dependent variable divided by the independent variable, just like we've seen before. So let's look at this graph here. Keith plants a seed. Every 3 days after the seed sprouts, he measures the height of the plant, and the graph shows the result. What is the constant rate of change for this relationship, and what does it tell us about the growth of Keith's plant? So here we see that this is a proportional relationship because it's a straight line and it passes through the origin, because at 0 days he had 0 millimeters of plant. So I can use any one of these points. 3 days, 6 millimeters, 6 days, 12 millimeters, or 9 days, 18 millimeters. I can use any of those to find my constant rate, or my unit rate. And it's going to be the y value divided by the x value. So I could pick the first one and take 6 divided by 3, or the next one, 12 divided by 6, or the next one, 18 divided by 9. I could choose any one of those because these are all equivalent ratios, which they all equal 2, and that's 2 millimeters per day, because my y value is millimeters, my x value is days, so that's millimeters per day. So what does that tell us about the growth of the plant? It tells us the plant grows at a rate of 2 millimeters per day. So now we've seen that when it comes to proportional relationships, the key idea here is that constant rate, that constant unit rate that never changes. And now we see what it looks like in a table, and now we see what it looks like in a graph. So we can get that information from either of those representations of proportional relationships.